Okay, looks like we have enough people here, so I will start our section now. Just want to double check you guys can hear me correctly and you can see my iPad correctly without no problem. Okay. So today first I will give you some announcements. So first of all, we will have a quiz, and it is submitted via Gridskope. So I want everyone right now to go to Gridskope and see if you have a section that like I created yesterday on like our sections. So it should be called like discussion section 201, 202 or something like that. Like go to Gridskope and make sure that you have that. And then click that and make sure that you have like a assignment called quiz 8, which is due like 10:40. Okay, all good.
Oh, I have a question. Do we access the quiz from B courses still, or is the quiz also going to be released on Gradescope?
The quiz will be released on the file tab in B course, and then you have to submit it in the Gridskope. Is that clear for everyone?
Yeah. Okay.
Okay.
Thanks.
Yeah, I mean, there might be an option to also release the quiz on Gridskope. I haven't figured out yet, but like in the future, I might figure it out. But for now, I'm like uploading the quiz on B course. So yeah, we will have a quiz. It will be like 10:10 to 10:40. And also you need to like submit homework by 11:59 a.m., not p.m. So like it's due in 2 hours. Don't forget to submit your homework. This is like on B course. This is on Gridskope. And is there any other announcements? Yeah. So for this section, I'll spend the first about like 25 minutes on limit theorem, and then we will do quiz, and I will spend last 20 minutes on continuous random variable. Like there isn't like too much about continuous random variable. So we should be good on this. And attendance will be taken during the quiz. Yes. So like you have to be here in the during the quiz. And then fourth, I will not have an office hour on Friday. Like maybe I'm not sure yet, but like currently we're scheduled a meeting on Friday for JSM meeting. So like if you do want to attend the office hour, probably I don't know, like attend on Wednesday, or you can like check on Friday, see if I was there. If not, send me emails. Like you can also like include words and images like describing your situation. Like usually I respond the email pretty quick. But like sometimes I might forget. So like if I haven't respond in 48 hours, that's probably when I forgot your email completely. So like send me a reminder. Yeah, otherwise I think I'm pretty like easy to approach. So yeah. So like I'm not sure the status of office hour now, but like maybe I will have to like swap to another thing, or maybe I'll just like stay now, and then you guys can send me emails and questions. So that's all the announcement, and I will start talk about limit theorem. So like theoretically, you guys should be able to finish all the like questions on the worksheet for limit theorem, because like you have already submitted your homework. But like still, I need to like go through the problem, like to make sure that you guys understand it completely. So several reviews on lecture. So for limit theorem, before stating every theorem, there's like a table. So if we have like a random variable x1, x2, up to xn, they are identically and independent and identically distributed. And the expectation of them are mu, and the variance are sigma squared. Standard error is sigma. And if we define x bar to be the average of this value, this x1 plus x2 plus dot 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 plus xn over n. The expectation is mu bar, which is equal to mu, and the variance of this x bar is defined to be called sigma square bar, and it is sigma square over n. The standard error is sigma bar, which is sigma over square root of n. And we can also normalize this distribution into a z-score. The reason why we do a normalization is because we want to like standardize each of the distribution. And the way we do that is we first shift the distribution left or right into when the mean is close to 0, and then we also like do modification on variance and make variance 1, so that with the standard error is also 1. With all like this information, like whenever I tell you like how many standard deviation above the mean, you can immediately know the percentile. And given a percentile, you can immediately know is that like the below or above mean, like how much is it below or above mean. So it's a good way to like standardize things. And it's defined to be x bar minus mu bar over sigma bar, where like these two are constants get from here, and x bar is has their own range. It has own range, so the range of z depends on range of x. So basically, you want to calculate the range of x, you first identify the range of x bar, and then you just do these functions, x bar minus mu bar over sigma bar on all range of x to get the range of z. I mean, that's like during my office hours, some of the students ask me question about range of z. And law of large numbers. So that's basically if you have a lot of like trials, so like x1, x2, xn, and then a lot of them. And theoretically, if we do like infinity amount of trials, x bar stabilize at mu. So it's kind of like mu is your theoretical average. And then if you do like a lot of trials, with like infinity trials, at last it will eventually stabilize at your theoretical result. And central limit theorem is basically saying that if we like normalize, so like z is a normalized curve, and then we can use like normal distribution to approximate the distribution. So like so the probability of z greater or equal to a less than b is defined to be 1 over square root 2 pi integral of e to the negative x squared over 2. So that's kind of like if you have a normal curve, and that's the function for the normal curve, like with the constant here. And then you are given like 2 points A and B, and you want to find the area of this in A and B. That's like this area. So you do an integral on this function to get the area. Yeah. So that's it for review. Let me know if you have any question. If you don't have any question, I will just like give you 5 or 6 or like minutes on looking at discussion 16, problem 2. So like just reminding you on the theorem, and then I will quickly run through the solution for the problem. Group back up. So which one? I'll just leave it here. All I mentioned. Yeah, please take some time on problem 1 in section 2 limit theorem in discussion 16. Just like read through the problem, and I will go through the problem pretty quick. So just be aware of that, and yeah, read through all the problems. Like you don't have to calculate them all. You just like write some like intuition or like the first step. How do you solve this problem? Make sure you like you know how to start and you know how to do the problem. And yeah, I would just like go through it pretty quick. Okay, let's go through the solution together for this problem. So let me read out the problem first. The problem says if we have like an experiment, and within each of the experiments, I flip a coin twice, and then count the number of heads to be x1, x2, up to xn, and x bar is defined to be the average of x1 to xn, and z is defined as this. So we want to first find the range of X bar. And mu bar and sigma bar. So each xi is a random variable. So if you want to, so maybe like let's calculate the range of X bar first. So X bar is defined to be as this. So if we have like if n is equal to 5, that means X bar is equal to x1 plus x2 plus x3 plus x4 plus x5 over 5. So for each x1, it can be either 0 has or 1 has or 2 has. Similarly, apply on all 5 random variable x. So for each X bar, the range can be 0, 1 to 10. Like 0 happens on all 5 experiments resulting in 0 heads, and 10 are like all 5 experiments are 2 heads. So that's and then we want to calculate. So that's the range of X. And range of X bar is like everything divided by 5, because we're dividing by 5 on X bar. And then if you want to calculate mu bar, remember mu bar is just the expectation of any random variable x. So xi, where I is 1 or 2 or 3 or 4 or 5. And remember, like since this is the binomial distribution, like this is like several Bernoulli trials. So it's actually each random is like 2 trials, because like each x1 stands for like 2 trials, and then the success rate is half because you have a half possibility to get ahead. So expectation of each random variable is 1, and sigma bar is sigma bar is defined to be as E standard error of xi, each random variable divided by the square root of n. And how do we calculate the standard error of xi? That's just the variance of xi, the square root of the variance of xi. And remember, the formula for calculating the variance for a binomial distribution is NPQ, where Q is the failure rate. It's 1 minus P. So that's just square root of two trials, success rate times failure rate. So that's 1 over square root of 2. So the standard, the sigma bar is 1 over square root 2 over square root 5, which is 1 over square root 10. And then we want to find the probability mass function of X bar. So remember, X bar can be 0 over 5, 1 over 5, 2 over 5, up to 10 over 5. So what does each of these numbers stand for? So like 0 over 5 just stands for like there are like 0 screen froze. Is it good now?
Yeah, it's good now.
Oh, okay. Yeah, it happens. So like to remind me whenever it happens. So we want to find what's the meaning of X bar equal to 0 over 5. That means none of the 10 trials. So 10 comes from 2 times 5 random variables, and each random variable has 2 trials in that. So 0 over 5 means that none of the 0 trials happens to be ahead. So that's just 10 choose 0 times half to the 0th power, half to the 10th power. So that's the binomial distribution over 2 to the 10th, because each one has the possibility to be true or false, or like you can do like this over 1. So that's the probability outcome space. So which is equal to 2 to the 10th or 10 choose 0. So similarly, this is 10 choose 1 over 2 to the 10th, and so far and so forth for all the other things. So that's part A. And for part B, we want to calculate the solution for x bar minus mu bar is greater than 2/3. We know that mu bar is equal to 1. So basically, this problem is asking us x bar minus 1 is greater than 2/3. So remember, like, look back into the range of x bar in the first page. And if you look it through, only 0/5, 1/5, 9/5, and 10/5 satisfy this condition. And for part C, if you want to calculate the probability of x bar minus mu bar is greater than 2/3, that is just the probability of x bar equal to this plus x bar equal to this and this and this, sum it together, and you will get the probability. Part D, if you want to find the probability of x bar minus mu bar that is less than 2/3, so we can just use the complementary counting to use 1 minus x bar minus mu bar greater than 2/3. So that's the solution from part C. We can also like compute it quite easily. I'm not going to detail on this easy problems. And for part E, the problem is x bar minus mu bar absolute value is less than 2/3. We want to like write it in form of z is greater or equal to a and less or equal to b. So remember, z is defined to be x bar minus mu bar divided by sigma bar. So for this absolute value, we can first split it into x bar minus mu bar less than 2/3 or x bar minus mu bar greater than negative 2/3. And we know that mu bar is 1. So these two equations can be written as x bar is less than 0/5 and x bar is greater than negative 0/5. And remember, like, this is just yeah, maybe I should do the z first. So remember, like, z is defined to be here, and then we need to like divide it sigma bar on both sides to make this equal to z, and then we can just simply plug in the number. So in the first scenario, z is equal to 2/3 sigma bar, which is 2 times square root of 10/3, and z is also greater than 2/sigma bar negative, so greater than that. So the answer is z is greater than 2 times root of 10/3 and less than 2 times root of 10. Yeah. Yeah, it's hard to tell you like to read this loud, but like the written part is pretty self-explanatory. And for part F, we need to use a standard normal table to approximate the probability of z greater than a less than b. So we know that a and b are these numbers. So the quiz will start at 10:10. So a is negative 2.11 and b is 2.11 here. So we need to calculate this probability. We look up normal table and find the answer. I'm not going into detail here. So for G, what is the relation between the probability of x bar minus mu bar greater or less than 2/3, and the probability of A is less than B, and the number you got, and the answer from F. So like these two are equal because we basically divided by, so this to here is like division by sigma bar. So the probability here is equal. And the answer, the approximation from part F is the approximation on these two probability. And because of central limit theorem, we are guaranteed that if the size of the population is large enough, I mean the size of the samples is large enough, we can the approximation is a good approximation. So that's the relationship between these three terms. And for part H, so if we did the same thing when n equals to 10 instead of 5, what will happen? So so according to law of large numbers, when n is increased, that means the x bar, like the x bar is more close to mu. And if we want to compute the probability of x bar minus mu bar is less than 2/3, this will increase because originally when n equal to 5, the distribution might be something like that. And this is the area for this probability. But if we have n equal to 10, according to large law of large numbers, it will be more close. Like maybe this way, I guess. It will be more close in the middle than the n equal to 5. So this is the probability of when n equal to 5, when n equal to 10. So the probability will be increased. Yeah, so I just quickly went through the problem, and if you do the homework, it should be like simple to you. But yeah, if you have a problem, you can like ask me later, because we will have a quiz right now. So let me upload the quiz right now. So if you go to B course, you should be able to access quiz 8 under the folder files, and then like before 10:40, you have to submit it on Gradescope. So you guys can start now. And also like I would like to ask you, each of you, to turn on your camera so I can like see what you're doing, like just like a way to prevent cheating. So please turn on your camera.
Yeah. I mean, but that's how I'm hearing him.
Can we look up like a standard normal table, or is there one under files or something?
Yeah, you can do that, but like you don't need that in my quiz.
Okay, cool.
Okay, seems like there's still some people who didn't turn on their camera. Like you have to turn on your camera or explain why you can't turn on your camera to be eligible for the quiz and attendance.
I have a question.
Maybe after the quiz, because in the
It's
quiz I
about the
didn't
quiz. It's about the
Okay.
quiz. So
Oh,
for
okay.
the true and false, is this asking if x and y are random variables with covariance?
Oh, yeah. Okay, so I want to explain several things. So the first thing is that in the true or false, the bracket of x, y is the covariance of x and y. And in written problem 1E, the bracket of z is the variance of z.
Okay.
Yeah. Yeah, written problem 1 is identical to the problem I went through in the discussion. So like, and I will allow quick correction afterward. So I don't mean to like give you guys low score, but I don't expect too much of you to finish in this limited time. So just do the best you can, and then I will allow quick correction afterward.
Is the quiz due by 10:40?
Yeah, the quiz is due by 10:40 on Gradescope.
Okay, thank you.
don't look at your computer screen, look at your own work.
What if the quiz is on the computer screen?
And don't look at your screen for like 5 minutes.
Wait, so for the written question, E, what are the brackets?
That's the variance.
Variance.
Yeah, I think Sarah just come, so she might be confused with that. So I'm just like copy and pasted the thing I changed again here. So
For C, is it the variance or covariance that we're finding for?
for C, that's covariance.
Oh,
So like whenever there's a bracket, so the bracket thing is like kind of stand for variance, and then there are two random variables in there, that's covariance, and there's one random variable in there, that's variance. And also for like part F, you just need to pick one value and compute the probability. You don't need to like do the whole thing.
Do we need a table of standard Z values?
Sorry?
Or do we need a table of Z values? Or-
I don't think any question need normal tables.
Okay.
Is it E that you said the brackets mean variance?
Yeah, the bracket of two random variables inside is the covariance of these two random variables.
X brackets, is that variance?
the covariance, yeah, if there's only
E.
yeah, E is the variance. I
Okay.
also like mentioned it in the chat. Yeah, be sure to submit it on Griscope instead of Bcourse.
So for 1F, we just have to draw a single dot for the PMF.
Yeah, but like mostly I'm looking for like the probability itself. Like
Okay.
like sketching is just an optional.
Oh, okay.
Would you prefer if we uploaded a file or a PDF?
I can't hear you.
Would you prefer that we submit a file or, I mean, like photos or a PDF?
PDF, please.
Yeah, I'm just using my phone to scan my quiz right now, so
Yeah, it's fine.
okay.
Yeah, quiz will be due in 4 minutes. So if you didn't finish, wrap it up and like scan it, submit. It's okay. Don't worry about that. I don't expect like too much of you to complete the quiz. I will provide a quiz correction. I just want to make sure that every one of you understand how to do this problem. Why are people keep submitting the quiz on B course? So,
See how my computer is like losing connection, so I just emailed it to your Berkeley email. Is that okay?
it's okay for now, but you have to submit it.
Yeah, but I just wanted to submit it before 10:40.
Okay. Yeah. Okay. I added the deadline.
Did you get
to
the
be
email?
10, yeah, I got the email. I added the deadline to be 10:42 and a late deadline to be 10:45. So if you have technical issues, you can like restart your computer now and yeah, and then submit it.
Okay.
Are we turning it into the grade scope or the
Yeah.
B courses or both?
Grade
Just
scope.
the grade scope?
Yeah. Please
Okay.
turn it into grade scope. Like the reason why I have a B course thing is I'm afraid that people will not attend the section but still want to do the quiz. So, and then I will know who are the students who are not taking or not attending the section, and then I will send them an email about like grade scope thing. Okay, time's up. Submit your work.
Yeah, I feel it. Yeah.
Okay. I guess most of you has already submitted your work. We will continue. Oh, before. Oh my God. I feel like some people just left. Like I haven't taken attendance yet. So shorten URL. So I'm like sending out the link for attendance. You guys need to fill out the attendance form. Yeah, it's okay to just turn on the click on the blank page as long as you label each question clearly. So like go to the link I just sent in the chat in Zoom, and then fill out the attendance form. Okay. Seems like people are filling out the attendance form, and I don't know. There should be more people attending my section, and someone just left like 1 minute before I send out the attendance form. That's really sad. I don't know how to handle that, but like I don't know. I'll figure out later. Okay, so back to our discussion. So if we go to discussion 17, there will be some questions, and like they are pretty easy problems. So I will first give you a little bit summarization on random variable, like continuous random variable. So basically, for what we encountered before are all discrete random variables that, for example, like binomial distribution, we only have like certain success. Success can be 1 or 2 or 3, but it can be 1.5. But if we are talking about continuous random variable, for example, like the waiting time in a train station can be a continuous random variable, and then so it can be like on a real line. It can be like any sort of number. You can wait for like 1.5 minutes. You can wait for like 1.6794 minutes. Because time is continuous. Although like in quantum theory, they have like a discrete time theory. But like we treat time as a continuous thing here. And then like so we define a PDF, which is a probability density function, as a function that has like continuous variable that given a number given for any x in real numbers or negative infinity to positive infinity, there is a value for fx. So that's PDF, and CDF is just like the area underneath the curve. So it's like a integral from negative infinity to some sort of a fx dx. And the thing is that because it is a probability, so the sum of the total outcomes has to be 1. So the sum of infinity to positive infinity of fx dx has to be 1. And because we're talking about areas. We're talking about like integrals. So if you do, for example, an area from a to a, f(x) dx, that's always 0 because
Yeah, your screen's frozen.
oh, okay.
Again, it's just a blank white screen.
Okay. Wait. Stop monitoring. Screen sharing. Did you say things right now?
Okay, yeah, now it's good.
Okay, so what I'm talking about is that it's just like for any x in this there in this range, there will always be a value of fx if it is continuous random variable. And since it is a probability, so for like all the situations summed together from negative infinity to positive infinity is always 1. And since we are talking about the area underneath the curve, so if we are integrate from a to a, that's just a line underneath the area of a line is 0. It's always 0. So just this is 2 things you need to remember. And this equation defines a valid PDF. So maybe we can go to discussion 17 and look at problem 1. I will just lead problem 1 through because that's just a warm-up problem. So problem 1 says that let ft denotes the PDF that takes in minutes to get from Berkeley to San Francisco by BART. Right, the probability that trip takes less than 40 minutes. So we want to find the probability of x less or equal to 40 minutes. That's just the same thing as finding an area of ft that is less than 40. So that's from negative infinity to 40, fx or ft dt. But in the real scenario, I forgot how to pronounce spell scenarios. Let's say real situation. Time has always be a number greater or equal to 0. So the probability of x less than 40 is just 0 to 40 ft dt. You can also treat as ft in range of it's 0 when t is less than 0. So with my screen froze again? Yeah. Yeah. Okay. So with that in the mind, please work on problem 2. Yeah. Yeah. Maybe my screen was frozen again, but like that's what I went through, and that's the solution for part A. Yeah, I just want to explain the reason why I let you guys to submit the quiz on Gliscope is for in the future I'll probably allow in some cases I will allow you to submit a quiz correction. So in Gliscope we have like a quiz request option, and then it's easier for you like to do a quiz submission, quiz correction. Yeah, I will like follow up the specific rules for quiz correction later. Okay. Let me go through a solution for problem 2. So for problem 2, we're defining a function to be some constant times x times e to the x squared, when x is in the range of 0 to 1, and it's 0 otherwise. So we want to check if it is we want to like find the value of this constant c to make sure that this function is valid PDF. So how do we do that? So if we want to check a function is valid PDF, we need to like check from negative infinity to infinity of fx dx, if that's equal to 1 or not. So what we do here is we check from fx dx from like negative infinity to infinity, and we know that this is equal to 3 areas combined from infinity to 0 plus from 0 to 1 plus the area from 1 to infinity of x dx. So we know that this is 0 because from when x is not in 0 to 1, the function itself is 0. So the integral of this function is definitely 0. So we know that it's 0. Same thing applies here, because we know that x from 1 to infinity, anywhere here, the function itself is 0. So it's 0. So the integral is always 0. So all we need to find is from 0 to 1 fx dx, what's the value of that. And we know that fx is cx ex squared dx. We just want to integrate that and find the value. How do we do that? We do like substitution. If you still remember in your calculus class, we do like u equals to x squared as a substitution. So du dx is 2x. So so dx is equal to du over 2x. So we plug this in. That will be 0 to 1 c times x times e to the u times du over 2x. So this 2x cancel out. That's 0 to 1 c times eu, like to du, and there's a half here. So how do we do that? We take out the constant, and we know that the integral of e of u is just e of u itself. So the answer of that is 2 over c times e minus 1. Like we just plug in 1 minus 1 and 0 and do a minus here. So remember, why are we doing the integral thing? The reason why we do this integral is because we want to check if the area underneath the function equals to 1. So we need to check if it's equal to 1. So when it is equal to 1, that's when c is equal to e minus 1, 2 over e minus 1. That will result in this equal this integral to be 1. So c equal to 2 over e minus 1 is the only c that make fx a valid PDF. Okay, so if you have any question, you can feel free to ask. If not, I'll probably just work on 3A to like reiterate what you have to do on those problems. So for 3A, that's the same problem as problem 2. But in this case, you define fx to be 3x squared, and x is only defined in 0 to 1. It will be 0 otherwise. So so for this function, we just need to integral from infinity to positive infinity fx dx to check if it is 1. But we know that x is only non-zero when it is in this range. So instead, we only need to do integral from 0 to 1, 3x squared dx. And we know that this is precisely x to the cube, 0 to 1, which is equal to 1. So good. This is a valid PDF. And for B, this time fx is equal to x. And x is still 0 to 1 and 0 otherwise. So we need to check from 0 to 1, fx dx is 1 or not, which is 0 to 1 x dx, which is equal to x squared over 2 from 0 to 1, which is half, which is not 1. So this is not a valid PDF. So in summary, what you need to do for checking PDF is you first identify the function fx and its range. Like it should be defined from infinity, negative infinity to positive infinity, but you also need to check where are the zeros, where are so like the function can be like equal to something when x equal to when x less than a, it can be equal to something when x is greater than a. So you need to like sum the integral. And the second step is to check the sum of these different steps of the function integral is equal to 1 or not. If it is equal to 1, good, it's a PDF. If it is not equal to 1, then it is not a valid PDF. So we asked the question, why didn't you check the continuity instead, or like in addition? I mean, theoretically, we have to check the continuity, but I'm not sure like if the professor asked us to do that, because that's a pretty mess thing. So I mean, it's definitely good to because you can't take an integral if it is not continuous. I mean, I don't think we will provide you two like tricky functions on proving its PDF. It has to be pretty much defined on negative infinity to infinity. So as long as the function is defined in this range, you can like take integral at any time. And I don't think it needs to be continuous. It just needs to be piecewise continuous. Yeah. Does that answer your question? Okay. Okay. So I will wait for 2 more minutes to see if you have like extra questions. If not, I will like end the meeting at 11:02. Thank you. Yeah, I guess it's already 11:02, and none of you has asked me any questions. So I guess you're just not here. If you do have a question, send me an email. If not, I'll just end the meeting now. See you guys.